I did a recent tool giveaway as a short, so please don't miss that. But in this video here, I've been asked a lot about this box here. And, you know, I think it's kind of my perfectionist type mentality that kept me from doing a video on this, because ideally I wanted to have everything perfect and like I wanted to have a schematic and all of that. But I think I'm just going to talk about this thing and show it. And I feel like if you're interested in it, it's probably something you can make, even if you have to vary your design from this. It's very open source. All these parts, there's not necessarily a name brand exactly that you need. You can do it a lot of different ways. So maybe that's the best way to really teach this. Now, what is this box? Well, in all of your high efficiency equipment, you're not doing old school metering devices. You know, we're not, certainly no pistons, but we're also not doing TXVs. We're doing what's called EEVs. So this is controlling the refrigerant, this. And as I got to working on this VRF equipment, I started to notice that there were a lot of similarities between the manufacturers. Oh, here, this is cool. This is really cool. I hadn't gotten this bag in a while. All right. So that's the only, man, I thought I had, oh yeah, I do. Okay, here's a Daikin. Here's a Daikin one of these. Exact same looking thing. In fact, like same threads. Now I've taken the nut off that, but I noticed it was the same thread. I'm pretty sure it's the same manufacturer making these. This is an LG, and this is a Daikin. Okay, and you've seen these in a lot of videos. Now, you can test these on the equipment, and it's easiest. Well, let me back up. Here's what this thing's doing. This is one I cut open, okay? So you have a little teeny stepper motor up here. I mean, it's a teeny little guy. And it's turning these gears, and it's really geared down, like super geared down. And it's just moving that little pintle, I guess. And that, in turn, is opening and closing that valve. I believe this position right here is, well, we could figure it out, but, well, yeah, I can. All right, yeah, exactly. This is normally open, and that makes sense. I just wanted to make sure there. But this is normally open. Now, these are supposed to seal, not here, but like here. And you can have some fights with the first generation LG stuff, man. Taking these off when it's under pressure and this little thing pops up, then try to thread these threads. Anyways, if you've been there, you know what I'm talking about. So refrigerant's being metered just by this little pin that's going down and sealing against a seat if it wants to be completely closed off, or creating like a spray, right? And I believe the flow on these, yeah, I'm starting to get more into this video now that I'm, sorry, I didn't look at all this. Yeah, I want to say the flow is, yeah, I'm thinking it's that way, whatever. Okay, so you can test these on an indoor unit pretty easily. What you do is you go into your software and you run the entire system in wide open cooling. Okay, and so all of your EEVs, if the system is charged right, the logic within the system itself is going to start dialing these EEVs down. So it's going to start shutting them down, and they're going to start ending up in the minimum positions, and you're going to see that listed out in your software, that this EEV is kind of like close to its minimum, close to its minimum. And if they're all close to maximum, then almost always that indicates a low charge. And technically you should charge these by weight, but you know, you're working at midnight at a nursing home trying to get them going, or even just, you know, really busy. you can get good at it, and just like with a mini split, you really do need to weigh it in to know what you're putting in there. But I have done repairs where I've got them going and then got it back out, and I got to where I could get it pretty close just by looking at the software and watching what these are doing and watching some other stuff. Okay, so when your whole system is running in wide open cooling, you've got all your indoors are, metering refrigerant. Now, if you shut an indoor unit down, like tell this, close down, like turn off, don't cool anymore. Now with Daikin, you got to be, always do this in cooling. Don't do it in heat mode. Different things are going on that just can really get confusing. Always cooling, wide open cooling. You shut this down and you watch your sensors. You watch your pipe in and pipe out sensors. And if this is truly shut, then those two measurements are going to start to equalize, and you're going to get, it seems like normal error might be like a degree or like maybe 2. I mean, these sensors sort of degrade over time, so or some of them completely fail. And so one of the things you need to be doing on a PM is checking your EEVs. Now, if an EEV fails on an indoor unit, that's pretty easy to diagnose. But if something like a subcooling EEV or a main EEV on an outdoor unit fails, woo, that can get tricky. Now, like a real good Daikin guy, and I've worked with some of the best in the world, can use that software and really kind of knows. I mean, just it's almost like a gut sense along with just tons of experience and watching numbers. And I'm making it sound overcomplicated, but you can kind of learn where your temp sensors are and learn what they should be doing when this is doing something specific. But I always really like just to see stuff. So if you want to see something, can this move? Because sometimes what's happening is that yes, this can move, but maybe it chipped a tooth. So like it's got some range of motion, but then it just locks up when it gets to this point right here, That's where this comes in. Enough blabbering. This guy. This is a driver. A stepper motor driver like module. It has everything you need in it. So this is a 4mm banana jack connection. And so that's where your multimeter leads can go, because this is also a power supply. Now it's not current, well, yeah, it is current regulated, but to use this on, like, say a 4 milliamp to 20 milliamp sensor, that's kind of tricky. Those low amperage, you really just need another device, and you can get a generic like signal generator for $30, okay? But you can still, I can feed voltage into circuits, and that can be a super useful diagnostic tool, but you have to be really careful, obviously, with what you're doing. All right, so here it is. And like all my kits, it looks like a pack rat's gotten in here. I just load them full of shit, okay? So let me go through what I've got in here, right? First thing that I keep in this kit is some leads, because this was like a grab and go kit. I would kind of just have it, if I wanted to generate some signals, bam, right there, because I kept like needle probes in here. And for those of you, there's a lot of things that automotive could learn from HVAC. Tons of things that HVAC could learn from automotive. You don't have to pay huge money for this stuff. You can get a nice set of piercing probes on Amazon. Although, my favorite brand is like Field, Peace, and Fluke. Nice set. And as is common in automotive, these are stackable. So you can have multiple channels like stacked, taking different readings, say with an oscilloscope. Well, do not, this is my main disclaimer, don't get into high voltage with this. This is totally low voltage, and that's why I'm using stuff that's not necessarily rated for high voltage. Okay. Some jumpers, because sometimes in really unique situations I was needing to like feed into different things. This lamp cord with this RCA connector, I think I'm saying that right, but this is for if you really want to get into awesome high quality connectors, you got to go with like the, man, is it RCA? It's like, you know, remote controlled cars and shit, drones and shit. They've come up with the highest quality connectors by far. These are 4mm or the same style, maybe 3. So much better than your like cage style that you get with a lot of cheap ass multimeters. You can see it in there. See that cage? That shit. Stay away from it. Unless it's from like Fluke, you know, they got the tempers perfect. You want something really great, get that. This style of 4mm banana. Okay, enough of that. So what have I fit in, and what have I put inside of this box? Well, you've got this, because I wanted to be able to power it off of mains, but also wanted to power it off of 12 volts, so hang on. I apologize, I thought I had this battery ready to go. Okay, so you can, all right, here's another, these are like breadboard or Arduino type connectors, and that can allow you to back probe into some other brand or some other connector, or front probe I should say. You can't always back probe these connectors. A lot of automotive connectors can be back probed, but in some cases on mini splits and different things, this is so small it's hard to even get a needle back in there. For feeding into like a controller, like a Train SC or something. So I got this buried in here. Let me get it out. Now it's been a while since I've used this, so give me a second. Alright, here we go. It's just the controls on this aren't quite intuitive. But what this is a little module, like power supply. It's not a signal generator. Like I was saying, there's a difference there. These don't have super fine control, but they have great control. So what I can do is turn it on, and now you see my lights lit up, and I'm kind of at low voltage. So what I found is that these 12-volt batteries, you know, especially if they weren't full, hang around there, and to get a stable control, you have to step it down from what this is. Just a lot of times with your voltage regulation, you know, you're going down 1.5 volts in order to keep a stable output. So if this is 12, you can't really directly output 12. I wanted control because I didn't want to hook a 12-volt battery straight up to an EEV. You know, like, this is limiting the current. So if I do something wrong, or I connect something weird, or it's locked up, you know, it's just the voltage will drop out, and it'll like hold at that current that I regulate, and that's the reason for that. Now this is being fed when it's on mains from this. You know, you just get these off of Amazon. This one's like a 32 volt. A lot of printers go into Goodwill. Goodwill be full of these. You look for one that's like 32 volts, maybe like an amp. You know, if you find one that's 12 volts and can put out like 3 amps, that's a pretty decent power supply, right? So we're taking this regulated power and we're putting it into this. Oh boy, how did this go? Yeah, we're putting it into this board. Now this board, and I'll try to have some links, but this board is going to be like our COM board. It's basically the thing that's sending the signal to our driver, and our driver is here. And you know, it's probably going to have like transistors and shit in it, and see all these pinouts and stuff. Well, I went through and I figured out the wiring. So if you want to look at this, again, it's why I wanted a schematic. I just felt like I couldn't do this thing justice, but you can get it. You'll get it just fine. Just play around with it, you know. But look, this white. Woo, what am I doing there? Yeah, it's a little more than I thought, but anyway. This, man, that's a voltage regulator, but what was I doing there? Oh, I think this board does need a source of power that's pretty stable, so I decided to feed it with a voltage regulator into this board to get like your 5 to 12 volts. I think I'm feeding this board with 5, so I didn't want the supply voltage varying. So I'm powering the board with this voltage regulator. And then I've got white, yellow, orange, and green. And those are going to be, see the silk screened on there? Okay. Nope. Yep. And I've noticed that a lot of them are the same. So it shouldn't be that hard to get this figured out. And then here's my connectors here. Here's what I'm doing now. I've got this, I brought this thermostat wire up here. And these are just extra wires, so don't pay attention to those. And then I've got my, I think this is power, yeah, VCC and ground. And this is a drive out, so I put an extra connector in here. And this is, I can take this off, it's like a cap, and I can probe into any connector. See how I have those same things I was talking about for like Arduinos. They're just like nice, super nice, like they're the same pin size as almost all of these connectors. So you can literally use this in anything. So this is like a one size fits all. But I did find out that if you take a plug off a board, off an old board, just desolder it, you can put it in there and make everything just plug and play. So I've got, you can see how I've got that hooked up there. The black here, and then red and blue and green right in there. And this is the pinout. I know it's a little rough, but you know, a lot of you guys mess with this kind of crap, you know, on some kind of Aeon or something, and so I feel confident that just putting out some of these screenshots, if you slow down, take some screenshots and look at this, it'll come together. All right, so you can plug this little guy in and drive it. Now, LG drives different than Daikin, and maybe there is a way to have a single signal drive them both perfectly. But what I did was I had some known goods like this LG, plug that in, and then I had markings, because you can kind of change, I forget now, but it might be the COM protocol or exactly what it's, you know, what it's telling this driver to do right here. Okay. And I found that the LG, I needed to be in this middle section, and Daikin here. Oh, okay, so if one is stuck, I made a note here. You can go up to 20 volts to break it free. So obviously I'm not using this. I'm using mains, so I can take this up to 20 volts. But that's also kind of a sign that it's bad too. But you can do that as an experiment. You can start increasing the voltage and see how it responds. And when the LED light is let's see, on, you're pulling it in, and off, you're driving it out. So let's see if we can get this thing to work. There it goes. Yeah. So LED light on, she's going in, and then, oh, okay. This is the reverse button, and now I'm going to give it power. So is there actually this LED light on is in, off is out. Isn't that cool? Yes! Yes! It works! Man, my reaction when I hooked this thing up and got it working, oh, there's something so satisfying about building something and just watching things happen. I love it. Okay, now, word of caution. Do not drive an LED, or, an LG or any of these too far. Because in like older, shittier versions of them, this will come right out and just fall out on the ground. So you've got to get it lined up with this tab inside of there, and it can be done, but it's tough. Don't overdrive them. Just see if it makes some rotations. Go back in. Now watch it stop. Okay. Now, okay. So even these motors are very small. So even when you're maxed out, you know, you saw locked rotor amps is almost nothing, but some of them that are stuck, I remember setting this, and I could kind of see where it would pull more current when they're jammed up. All right, so the last feature, I mean, this is like a total troubleshooting kit on these VRF systems, because you need this signal generator would be nice, especially because like this is a power supply. If you want to start sending 5 volts into a circuit and seeing what the software does, God, for the love of God, be careful. Like, I don't want anybody frying, you know, like $1,000 boards and stuff. But if you understand how these circuits are designed, and I have a video on it, it's not that hard to manipulate them. So you can do that, or you can become the sensor, and that's what this is. Super cheap, off eBay. I'm sure you can get them off of Amazon. Just decade box, and it has. And I just bought this. There's no way I want to go through the trouble of making this when I can buy it for like $30 or something. But typically decade boxes are real expensive, and in the past they used to be a fortune. But now you just dial it in. Like, look, I mean, you know, that's 1 million blah 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 ohms. And so you can take this with your multimeter, and it comes with these jacks, this whole thing. You buy this whole thing, the box and everything. And what I mean is it's all assembled. I'm not buying this individual stuff and putting it in this box. This comes already assembled. See? Boom. And now you've got 2 probes to like go into a circuit. So you got a board sending out 5 volts. Now you can become the thermistor and do different things like that. So I love this kit. I realized it's kind of a niche thing, and that's probably also why I waited to do a video on it. It's like, you know, it's like I don't know how many people actually want to go through the trouble of building this. But hey, even if you don't want to build this, a signal generator is really nice. Just type in like, yeah, I'll try to put a link for it. But anyways, a power supply is really nice, and you can get these little modules. Now, you know, they might advertise 5 amps. There's no way I would let this run on 5 amps for a long time without like some cooling, or I don't know. So you're not getting super quality stuff, but man, it's doing everything you want to do. So whatever voltage I have here is also here. And that's the reason for this plug here. Because if I don't need a driver, but I just want a voltage generator, then bam, I can put anything I want to out these pins. And then any resistance I want, and then I've got my driver. Okay. Ask me questions and I'll do my best to answer. Oh, whoa, that was close. I had this meter up here. Check this out. This is pretty cool. I really think that, you know, companies like Fluke are, yeah, sort of, you know, yeah, we're not using 1980s screens anymore, man. Let's get into this kind of stuff. I had this meter. Oh, that's good. That's a good feature. But it's going to be better on a high-end meter like an Agilent or a Fluke, where it will not stop beeping at you until you have your leads in the right position. So if I went to, this is a great feature. If I went to volts and I was in amps, your high-end Flukes and stuff that have this feature, they'll be going ballistic because they're not going to want you to blow your meter up. But look at this. That's blowing your meter up. But man, look at this meter. Anyways, this is just one that I keep. But I thought I might have to do some stuff to figure out what the heck's going on here. And we could play around with it. Just let's do like a little overtime here. AC, yeah. You're probably out of this thing, like if I've got it on where I'm driving it. Now it's really a scope where you'd want to look at this. I don't know if we need to go full nerd. Okay, there's going back out. You're going to see probably some kind of pulse width sort of thing. Yeah, look at that. Meter's kind of, yeah, something jumping around. It's really this thing that, man, all this stuff is so fascinating. I'm just like probing random pins here. I don't even know what I'm, that's probably some kind of, you know, feed. Whoa, it just changed. Oh, that's because it maxed out and I got lucky. It didn't fall out either. Oh. Okay, enough fooling around. Enjoy.